Hey guys, and welcome back to UnicoDev. So, for the 1st of April this year, I decided to do something different on my main channel. Now, to be fair, it was something kinda confusing and maybe it didn't fit my main channel because like 99% of people were like, what the heck is going on here? But honestly, that's just what an April Fool is, so why not? So basically what I did is, I created an ARG style puzzle, where you had to put together the pieces, find clues hidden inside the video itself, in order to proceed and actually have a prize. Now, there was no prize. The only prize was, I'm not gonna spoil it, because if you want to try it by yourself, you can. But yeah, the prize is really underwhelming, like you don't win anything. There is not like $10,000 on the line, there is nothing like that. I mean, the actual prize is having fun, getting to decipher what the video actually means. And now, naturally, a lot of people were confused. They were like, well, we don't want to decipher that, we just want some content. Why would you do this on April Fool? But today, you're gonna have that content, because today, finally, after 3 months, actually after 4 months, wow. No, wait, it's 3 months, I cannot count, we are still in July. Yeah, after 3 months, I'm gonna explain what this video is about, how to decipher it, and also how I created the video, because it's pretty interesting. I actually used Unity to create and render the video, and it's pretty cool. So today we're gonna embark into this journey, but before doing that I'm actually gonna strongly advise you to try the puzzle by yourself if you haven't. So if you have no idea what I'm talking about, there is gonna be a link in the description. The video is unlisted, but you will still be able to see it. It's basically a really cryptic video that you're seeing on the screen right now too, and you just have to decipher it, so good luck. Now there is a thing I must say though, when the video was public, there was one extra thing that you could look at, okay? So think about it. When the video is public, what's a detail of the video that you can grasp? There is something that is there that when the video becomes unlisted, is no longer there, because you cannot find the video. Also, before starting, I want to say a big congratulations to the people that were actually able to, complete the puzzle, and you have their Discord names right here on the screen right now. Big props to you guys. I actually knew these people from my Minecraft community on my channel, and it was really exciting to see them actually being able to complete the puzzle. And a lot more people actually attempted and came really close, and I loved how there was a channel on my Discord where people tried to decipher the puzzle. It was really so exciting to see people, trying to mess around with things and maybe doing things that didn't even make sense just to try and find a solution. And honestly, I want to do this in the future because it was really fun to see that. Alright, so the first time you see the video, of course you're gonna know nothing about what's going on. But the first thing you have to notice is the sound, because the sound is not there for any good reason. I mean, it's there for a reason, that's what I meant to say. So it's a really spooky sound and a little bit of an ambient, weird music, which I actually took from a YouTube video of free, ambient sound music. And the funny thing about this is that someone on my Discord actually reversed the audio of the song, like reversed searched the audio, and found the original video where I stole the audio from. So that was really exciting, and not related to the challenge, but still pretty fun. Anyways, if you listen carefully to the audio, you're gonna realize that at some point there is gonna be a cut, and the audio is actually gonna turn into something kinda annoying to listen to. I'm gonna let you listen to it right now. So I made this first clue really obvious so that you guys knew where to start, where to begin with, because everything else is pretty cryptic. I mean, you have a letter on your screen, which is in an unknown alphabet, you have a color on the top of your screen, and you also have a grid of stuff, of random data that you have no idea what it means. Alright, so at this point, what you probably want to do is download the video, because, there are gonna be hidden stuff in it, so it's better to download it and, maybe analyze it with some external tool. So what you can do is use a converter online to download the video, but I've actually wanted to showcase this one, YouTube DL. So with YouTube DL, you can just do YouTube-DL and then the URL of the video, and you are gonna start downloading the video, and in this case it was already downloaded, so it's not gonna do it again. But yeah, it's gonna download the video to your home or whatever you want it to. And also what you can do is download the thumbnail of the video, so you can do --write thumbnail and then --skip video, so it's only gonna download the thumbnail, not the video. And then if you do this, it's not gonna work. Oh, it's skip download, not skip video. Okay, I copied it wrong from Stack Overflow, my bad. Alrighty, and now it's gonna download the thumbnail but not the video, so it's gonna put the thumbnail somewhere. And naturally you can use external tools for this, but I just think this is cooler. Alright, and once this is done, you're gonna have your video and you're gonna have your thumbnail downloaded. Also, there is other stuff in this folder that we're gonna look at later, but yeah, don't worry about that stuff yet. Alright, so now we have these two things, and the first thing we need to do is analyze the audio, because definitely something is going on with the audio, and we need to use a spectral analyzer or a spectrogram. Alright, so a very good one is Decode Spectral Analysis tool. So you can use this tool and analyze the audio of my video. And as you can see, I already did this, so if you go at the second 36, you're gonna actually see this stuff pop up in your spectral analyzer. Let's just reset it so, you know, we can show it again. As you can see, now it's playing the audio, that is very loud, okay. I think I missed it, so let's do a little bit before. Okay, so as you can see, all of this audio is normal. Oh, it actually muted it for real. Okay, that's bad. Let me mute it from the system. So all of this audio is normal, and then we have this insane pitched audio that is actually gonna show the code. And as you can see right here, we have this combination of characters. Now, a person that, you know, maybe did this kind of puzzles before is gonna realize, wait, I already saw these characters. These characters are at the bottom right of the screen. So there are 1, 2, 3, 4, 5, 6 characters, and we're just gonna copy these and, you know, just store them. So just for visibility, these are the 6 characters that we identified, and you may say, okay, nice Nico, we have these 6 characters, but what do we do with them? So basically, the video is composed of a lot of different frames, okay? And in every frame, there is a new color at the top left, and there is a new letter in the bottom right. But one thing that you might notice is that there are only 6 colors, while there are 24 letters. So the letters always change. There are like 24 frames and 24 different letters on the bottom right. Or I might say 24 different symbols. So what this means is that instead of taking in consideration the entire video, let's take into consideration only the frames that contain these 6 symbols. So let's go find those frames and let's cut them out. But before doing that, it might actually be useful to understand what these symbols actually mean. Now, maybe not everyone knows this, or I don't know how people could search for it, but I saw some people in the comments realizing this. These symbols are actually not a random symbol. Like, they are not random symbols. They are actually a well-known alphabet. And it's actually called the Standard Galactic Alphabet. And the reason I thought people would know this is because on my main channel I play a lot of Minecraft. And this alphabet is actually used inside of Minecraft. When you enchant stuff on the enchanting table, that's the alphabet we are using here. So if I write some English text like, hello... Sorry, I'm trying to use the other keyboard because this one makes too much noise and it's really annoying. But yeah, Blue Key's keyboard are really annoying. But if I do hello world, for example, this is the translated stuff in the galactic universe standard alphabet thing. Okay, there you go, and this is the translated alphabet. So now we can try to understand what these words actually mean, even if they're probably not gonna mean anything because they're only representing one specific frame. But one thing we can look at is actually the title of the video, because the title of the video actually contains those weird galactic characters. So let's translate the 2-character long title of the video, and the title of the video actually translates to QR. So this spoils that at the end of the video we're gonna get a QR code. Okay, great, but now let's actually proceed. So out of all of the frames of the video, let's actually only select the ones that contain the characters that we saw in the spectrogram. Now, I'm not sure how one would go ahead and do this, but basically the way I completed it myself was just taking a lot of screenshots from YouTube itself, and it actually worked, so you can do that yourself too. Or maybe you can download the video and try to find it. So, for example, this is one frame, but this is on the way, okay, and I'm just gonna take a screenshot of this, and I'm gonna save it. And I'm actually gonna use GIMP for this last bit, because, you know, GIMP is really a great tool for image manipulation and stuff like that. It's basically Photoshop, but for free, so why wouldn't you use it? So now I'm gonna paste what I just screenshotted, and as you can see, I made the sides of the GIMP thing just exactly the size of the grid, so we can work with it better. And now I'm gonna align it to the grid, okay? And I'm gonna actually paste this to a new layer, and I'm gonna call this layer blue because the color at the top right, top left was blue. Alright, and now you have to do this with every single, frame that actually has a symbol corresponding with the spectrogram symbol. And now when you will do this, you will actually realize that every color appears exactly once. There are 6 colors, which I think are blue, red, yellow, green, magenta, and I think light blue or something. And as you can see, every color is gonna appear exactly once in the 6 selected frames. Alright, so once you're done, your project is gonna look a little bit like this. So you're gonna have a magenta layer, an aqua layer, a yellow, a blue, a green, and a red layer. And we're gonna have a layer at the bottom which we don't need, so we're gonna remove it. And also at the top, I created an additional layer. This is the thumbnail layer. So I just took the thumbnail and I put it in here, because as you can see, the thumbnail actually also has a grid-like formation, but the difference is that the grid is colored. So maybe you already know where we're going to here, what's our destination, but as you can see, this thumbnail actually contains the 6 colors that are on the top left of every frame. So in this thumbnail, there are a bunch of red pixels, okay? What if we go in the red one? So let me just deselect all of the other ones and let's just select the red one. What if we go in the red layer, okay, in the red frame, and remember, this frame is the red frame because at the top it has a red. But yeah, what if we go in this frame and instead of selecting all of the pixels, we only select the pixels that are red in this thumbnail? Well, you might say, Nico, that's really tedious, how are we gonna do that? Well, you can do that using layer masks. Layer masks are a cool image manipulation thing, which basically tells your layer, okay, only render this part of the image. So we only want to render the red part of the image, or like the part representing the red pixels of the image. So what you can do is go to Tools, Selection Tools, and select by color, and go into your thumbnail layer, the colored one, and then select the red color, okay? And as you can see, I have selected all of the red pixels, okay? Now let's copy this, and let's actually create a new layer, and let's paste this. So let's create a new layer, and let's paste it. It actually pasted it above, okay, that's great. Okay, there you go. So as you can see, now we have a layer with only the red pixels. And, okay, if we remove this one, yeah, as you can see, this is a layer with only the red pixels. Now, from the red layer, we only want to select the pixels that are overlapping with this layer. So we only want to select the ones that are hidden once I enable this layer. Because this is the red layer, and we are selecting the red pixels. It makes sense. So what you can do is create a layer mask. So I can do add a layer mask to this black and white layer. So I'm gonna add a layer mask, and the layer mask can come from the selection. So what I can do is go into this layer, and actually I don't even need this layer, I can remove it, this was just to show it. I can go into the thumbnail layer, okay, I can do color select again, I can select all of the reds, and then go back into this layer, add a layer mask, and now we make the layer mask use the selection that we currently have, which is all of the red pixels. We do add, and as you can see, we're gonna have our layer mask. So if I remove this one, as you can see now, our red layer doesn't display everything, but only displays the pixels that are overlapping with the red in this thumbnail. And now you can actually do the same operation for all of the 6 colors, and once you do that, you are gonna get your beloved QR code. And so there you go, I did exactly that, and now you're gonna see the QR code appear. So this is gonna be the red part of the QR code, because you can see it matches the red bits. Then we're gonna have the green part, and as you can see, it's starting to take shape. And then we're gonna have the blue part, then we're gonna have the yellow, then we're gonna have the aqua, and finally the magenta. And as you can see, we have our fully completed QR code. And now I'm actually gonna scan this on my phone and see what this is. I want you guys to take bets if you have no idea what this could be, but I'm gonna scan it right now. I mean, obviously I know what it is because I made it, but, you know, it might still be a surprise. And you know what, actually I'm gonna use an external tool to scan this because I cannot be bothered to do it from my phone. And if we go and load that video, we are gonna have a beautiful Rickroll. Yay, that wasn't unexpected at all. I mean, that was expected, not, like, it wasn't expected at all. Yeah, that's what I meant. Yeah, a totally cool Rickroll, 100% amazing. This is what you all guys wanted. Okay, well, this was a wild ride, and, you know, it was really fun to create this puzzle. But now, what you might be wondering is, okay, Nico, but how did you generate all that gibberish data? How did you actually do that? Because, you know, that it was a lot of data, and, you know, you had to put the QR code together. Did you do that manually? Because I know that you are lazy, so you don't do stuff manually. So how did you do it? The truth is, I used some scripting done in Unity. And you might say, Nico, why did you use Unity? Couldn't you use, like, Python or something less overkill? Well, the truth is I'm really fast at writing code in Unity in respect to other languages, so that's why I wanted to use this tool. And also I wanted to use it because I wanted to do a video about it afterwards, and I feel like it was a great way to show how you can actually use Unity to do stuff like this. So, you know, in this part of the video, we're actually gonna go through how I generated this stuff, and actually how you can generate your own code, because the beauty of this, and of doing this in Unity, is that you can actually change, right here in the resources, you can change the QR to anything you want. So you can change this to any black and white image, and the pixels are gonna try to represent that black and white image. So if you want, you can encode in a video, like, different information in the same style. So you can create your own ARG for your friends, and, you know, let them try something out that maybe is not a Rickroll, but it's something a little bit better than a Rickroll. But yeah. Anyway, if you never used Unity before, it's basically a game engine. It was mainly designed for games. But yeah, we're not gonna go through the basics of Unity right now. I'm just gonna show you a little bit of the scripts and, you know, how the board making and the randomness actually works. But yeah, let's hit play and let's see what's in our scene. Basically, in our scene, we have a board that contains a bunch of pixels, and naturally the length of the number of pixels that is determined by the width and the height of the board. So every single pixel is a different object, and, you know, maybe this is not the best way to do it, because every single pixel representing an object, if you do a really big grid, everything is gonna lag a bunch. But, you know, for less than 1,000 pixels, we don't have to worry about it. And honestly, if you create a puzzle that which is like 1,000 pixels, nobody is gonna ever do that. It's gonna be really hard to manually do, so you need to use a tool like we used to complete it, and, you know, it's not gonna be fun. But yeah, every single pixel contains some data that we're gonna see later, and naturally it contains a color, because naturally every pixel has a color. And then there is also some data in the board that you can manipulate. Mainly, you can manipulate the frames, which are actually the letters, because if you guys remember, every single letter is a different frame. And also you can manipulate the number of colors. So if you want, we can also add a new color, and I don't know, it can be I guess it can be this orangish kind of color, like this. Okay, this is more brownish, but it doesn't matter, I'm gonna delete it anyway. If you do that, as you can see, a new color is gonna appear, and this means that the QR, or the image, is gonna be divided in 7 pieces, instead of 6. And this also means that the secret code that you see down here is actually gonna be composed of 7 letters. So in our spectral thingy thing, which I lost, yeah, so basically in our spectral thing, instead of 6 letters, there are gonna be 7 letters, because we need to have 7 frames, 7 parts, in order to represent the QR. So you can change the number of colors from here, from the board. You can also change the number of letters, so naturally more letters is more frames, so it's a longer video. You can also change the delay, I think, between one frame and the other. Yeah, right now it's like 3 seconds, you can change that if you want, you can change anything. And also you can change the seed. Now, I used a set seed because I wanted to reshoot the video multiple times in case OBS was dumb, and I actually wanted a seed that looked pretty random. Because naturally, if the colors are not... what is the thumbnail? If the colors don't look random, people might be able to understand it is a QR code, by only looking at one frame, because naturally if the blue takes over a big portion of a side of the frame, it's actually gonna look like a QR code, because you're gonna see the little square at the corners, and so I wanted to not make that happen. I also think there was like a reason I used these numbers, but I don't remember, like I don't know, that maybe an Easter egg, but no, it's probably, I'm trolling myself. I probably randomly chose those numbers. I have no idea what they represent, other than being the seed inputted for this output. But yeah, this is basically the scene, and now I don't want to show all of the scripts, even because there are not that many scripts. It's really just one that does the entire calculation. And then, you know, this other one is just for a pixel. So basically this script modifies the entire board, while this script only modifies 1 pixel at a time. So this script... there is one instance of this script, of this class, on every pixel. So it can do some helper method like setting the data of the pixel, modifying the color and stuff like that. And then I also have a script that basically loads the PNG that I put right here. So this PNG is basically a QR code, this one, and it will actually loads it into Unity, and will transform it, every single pixel, into a color. So this data is gonna be a color. So once we actually have that image, we are gonna initialize the board. What does it mean? It means based on the dimension of the image, we are gonna spawn a bunch of different pixels, based on the height and the width of the image. every single pixel is gonna contain this pixel handler script, and we're gonna make sure to put it at the right place in the hierarchy of Unity. And also we're gonna do these two things that are really important. We're gonna set a type for the pixel, and we're gonna set some data to the pixel. So the type of the pixel basically represents the color that it's gonna have in the thumbnail. So if we see the thumbnail right now, which is basically the first frame, this first pixel right here has a red type. The second pixel right here has an aqua type. This one has a yellow type. The data of the pixel instead represents the actual data that we are not encrypting, but we're hiding in the image. So this data is gonna be the QR code, or rather the value, which can be either white or black, of that specific pixel. And if you put all of the values together, you're gonna get the image that we had as an input, the QR code. So now every single pixel has this information that we want, and we have initialized our board. Then the next thing to do is actually show all of the types, which is basically means show the thumbnail of the video, so that I can take a screen and put it actually as the thumbnail of the video. So this is why the first frame is all colored, because it's actually the, the type of all of the different pixels. And then it will actually start generating all of the gibberish data and encoding the QR code into that data. This is done by the function showFrames, and basically this function is a coroutine, which basically means that it's gonna wait a few seconds before, proceeding, and naturally the seconds is defined by the value right here, the frame per seconds, which is 3 by default. We set it through Unity. Alright, but before generating our frame, we're gonna generate the frame data, and the frame data is basically gonna be the stuff at the top left and bottom right of the screen, so the random letters and the random colors. So I will take every single possible frame, which is defined in the frames array, which is the one right here. Basically, I will take every single letter. I'll make sure there are no duplicate letters, because, somebody could do this thing. Now, out of all of these letters, I only need a few letters to actually be the correct ones. All of the other ones are gonna be just gibberish, because if you guys remember, from the spectrogram, we only got 6 letters. All of the other ones don't represent anything. So from these letters, we're actually gonna take a random set of these, which is gonna be 6, because the number of colors, which are the types, is 6. So we're gonna take 6 random letters, and we're gonna put them in this variable. And now, for every single letter, which I'm gonna call frame from now on, so for every single frame, we're gonna check if the frame is present inside this, list of correct frames that we generated before. So basically, we are checking if the frame is meaningful or not, if it's gonna contain data or not. Now, if there is no instance of the distinct frame in the correct frames, this is gonna return -1. If there is an instance, it's gonna return the index of that instance, so it's not gonna return -1 basically, it's gonna return anything else. So here we're generating our frame data. We're gonna check if the data is actually meaningful by checking if the index is different than -1. Because if the index is different from -1, then it means that that letter that we're checking for is actually in the meaningful frames. So it's gonna be one of the 6 letters that are gonna show in the spectrogram. Then every frame is gonna have an ID, which is basically gonna be the letter that, that frame represents, which is gonna be what is gonna be shown at the bottom right of the screen. And then every single frame is gonna have a type, which is basically the color that is gonna be shown at the top left of the screen. And now, if the frame is meaningful, the type is actually gonna be already set, because it's gonna be the type of that letter. Because if you guys remember from the spectrogram, every single letter needs to have a distinct color that it represents. So the first letter is gonna represent magenta, so it's gonna have at the top left magenta. The second letter that is meaningful is gonna be aqua. The third letter is gonna be yellow, and so on. So this code right here is making sure the types of the meaningful letters are distinct. So every letter is gonna have a different color. If the letter is not meaningful, we don't care about the color, we're just gonna use a random one. Alright, and now we have all of the information we need about all of our frames, so now all that is left to do is iterate over every frame and actually display the data, naturally waiting 3 seconds in between those frames. So to show this frame, we're gonna show the letter at the bottom right of the screen, we're gonna show the color at the top left of the screen, and as you can see right here, if the frame is meaningful, then we're gonna show the type that we used before. If it's not meaningful, we're just gonna generate a random color. Naturally, a random color from the 6 colors that we can take from. And then finally, if the frame is not meaningful, so it's not gonna be in the spectrogram, we can just generate some random gibberish as the colors. So as you can see, this method right here is gonna go through every single pixel and it's gonna set a random color to the pixel. So it's just gonna, get a random color. Instead, if the frame is meaningful, we are gonna display the data of all of the pixels, but not the data of all of the pixels, but only of the pixels that match this type. So as you can see, this is the function that does exactly that. It's gonna take a type, which is the type of the frame, which is what is shown at the top left of the screen, and then it's gonna take only the pixels that have this matching type, which, if you guys remember, you can find the matching type from the thumbnail of the video, and then if that pixel matches that type, it's gonna set the data color, which is basically the QR. If it doesn't match that type, it's gonna set some gibberish, so it's gonna set a random color. And so this is an example how we generated the red frame. So this is the red frame, and as you can see there is a bunch of gibberish data, but if we only look for the red data, this is gonna compose our QR. And if we do it for all of the other ones, the QR is gonna show. And yeah, this is it, this is all of the code. Sorry if at the end it could have been a little bit confusing with the types, the thumbnail, and the spectrogram. But yeah, this is all I did. And Unity actually doesn't generate a spectrogram. There is probably a way to do it, but I used an external tool to do that, and I think I used it from a website or something. Now, I do not remember the website, but it was really easy. You could just upload an image and it will return the spectrogram of that image. And as you can see, this is actually the image that is shown on the spectral analysis. Oh, actually, never mind, this is the image that I uploaded, so yeah, as you can see, I made it with a lot of noise, and then white characters, so that, you would be able to see it really well. And that's it, that's literally all there is to it. Now you can change these resources and image to generate your own secret stuff, and you can also change the colors. Maybe we can do this with only one color. It's gonna look really stupid though, so if we do, let's do only 2 colors, okay? So there are only gonna be 2 frames. And as you can see in the console, it's also gonna see the correct frames. Okay, so yeah, V and N are the correct frames, and we are at the letter B, so it's gonna take a while to get to N. And now this is gonna be N. And as you can see, you can a little bit see the QR code, because, this is only half of the QR code, the other half is gibberish, but with 2 colors you can kinda decipher that this is a QR code, but naturally with 6 colors it's a little bit harder, so you cannot really do that. And also, if you guys are wondering how I'm translating these letters to the galactic alphabet, I'm actually just using a font. So right here we have fonts, and I have my galactic alphabet font. This was actually transformed into a TextMesh Pro font asset. You can do it from here, Assets TextMesh Pro font asset creator. So you just download the font, you transform it into this type right here, and you can actually put it into the text. So as you can see, it's using this font, and the text will automatically use the galactic font instead of, the letters of the alphabet, and it's gonna start displaying the different symbols. And this is it. Thank you ever so much for watching this video to the very end. I really want to do something similar to this because I have a bunch more ideas on puzzles that I could do. Honestly, I had such a blast making this and making the code for it. I coded it in like 2 days, so it was really fun to just do as an hackathon project. Thank you ever so much for watching till the very end, and leave a like if you enjoyed, and I'm gonna see you guys in the next video. See ya!